今のようなちょっと実語のようだけど、主体とね、それから環境っていう違いですね。主体と環境との関係ができるんです。ところがその主体と、環境というものが一つ互いに主体が環境というのを作る、環境が主体を作ると、そういうところに創造というのがある。
Zen was one of the main themes throughout Nishida's life. On discovering himself, Nishida came to Zen and nothingness. And in speaking of Zen and nothingness, he discovered himself. He tried to build a new thought through this procedure. And Nishida pursues the possibility of thoughts as such by studying Western philosophy on one hand, and the methodology of Zen philosophy on the other. Nishida's struggle first bore fruit as a book, Zen no Kenkyu, an inquiry into the good. After a few years, Nishida wrote in his essay, "What had moved me the most was the fact that my young daughters had died. What is life if those lovely speaking, charmingly singing children, playing just in front of me, suddenly disappear and are put into tiny graves as only a few bones? Life is nothing if life is only such a thing. There must be some meaning here." Life would be what he thinks. If sadness was the only thing he had withdrawn from life, life would just be sadness. But can it be so? There might be some more things hidden in life and what he had lost. This obligation to find something there led him to the foundation of his unique philosophy. One of Nishida's main ideas was to overcome the subject-object distinction of Western philosophy. What Nishida was paying attention to was the consciousness prior to differentiating a subject and an object experience, which he called Junsui Ishiki, or pure consciousness at the time. It was an arduous effort to comprehend and describe. Taking a look at an infant can give a good example of it. We can say that a subject and object experience is not yet differentiated in an infant's crying and mumbling. It has not yet found itself. However, it starts to say pa and ma and gradually begins to call itself me. A subject and object experience starts to differentiate. Self-identification and identity start to sprout as itself starts building up. Unfortunately, we tend to forget about these facts prior to self-identification and start our experiences upon concrete selves. Studying the philosophy of Nishida obliges us to reflect upon our selves in life in such a way. It has inspired him to have some new ideas and visions. He presents his ideas successively as Ippansha no Jikaku-teki Taikei, the self-aware system of universals in 1930, and as Mu no Jikaku-teki Gentei, the self-aware determination of nothingness in 1932. In the latter, he argues that basho, or topos, which is one of his key concepts especially in his late years, are a place that both subject and object are enacting and correlating as a whole. Nishida concentrated on this, his signature theory of topos, to his death, and developed it as nothingness, or mu, absolute nothingness, zettai mu. What he had stated within the contrast of the subjective being in ontology was a significance of this topos and nothingness, which may be called me-ontology. Nishida then focused on enacting correlations within the topos of absolute nothingness. Koi-teki chokkan, or action intuition, is the phrase he describes it with. he gradually starts to think about the energy that generates in a place and the effect that is active while someone is acting. In this way, Nishida reaches his maturity, and the phrase zettai mujun teki jiko doitsu, the self-identity of absolute contradictories, marks the essence of his thought. With the self-identity of absolute contradictories, in general, self-identity is a state where logic is clarified by means of a solid united self. In other words, it is believed as a condition that the contradictories are being overcome and therefore the contradictory have disappeared. However, what Nishida had said was the self-identity of absolute contradictories is a relation of the being and the world where contradictories are absolute as such and beings are related as a whole in self-identity. Daisetsu Suzuki, Nishida's lifetime friend, has called this sokuhi logic. Sokuhi, which literally means A is A because A is not A, is a saying that is very difficult to grasp. In general, is becomes yes, or it is. However, he states it as A is A because A is not A. So what does is not mean? The thought could come to a halt right there, but it is at this point that absolute affirmation takes place, which was quite similar to and was also deemed sokuhi logic by Suzuki, but slightly differed from Nishida's self-identity of absolute contradictories.
それは全ての人間はそれはできるわけなんです。できるから、それに全ての人間は創造性を持っているわけです。ところが、そういう世界と環境との一つになったような世界、一つの世界っていうものが、その時代全体の一つの傾向を持っている。その傾向に向かって進んでいくということですね。それがその歴史的世界の創造。そこにその創造を助けていくと、その創造に向かっていくということが、それが別の人間の道徳な別の文化っていうものの目的を説明するんだと、こういうことです。だってそれは創造っていうことは誰でもできるから、それでこの人間は創造性で動物と違うという。だから人間のこの目的が創造にあるということは、全て人間はできなきゃいけない。
Then along came Roger Penrose, who would ultimately get the number down to 2. Penrose started with a pentagon. He added other pentagons around it and, of course, noticed the gaps. But this new shape could fit within a larger pentagon, which gave Penrose an idea. What if he took the original pentagons and broke them into smaller pentagons? Well, now some of the gaps start connecting up into rhombus shapes. Other gaps have 3 spikes. But Penrose didn't stop there. He subdivided the pentagons again. Now some of the gaps are large enough that you can use pentagons to fill in part of them. And the remaining holes you're left with are just rhombuses, stars, and a fraction of a star that Penrose calls a justice cap. You can keep subdividing indefinitely and you will only ever find these shapes. So with just these pieces, you can tile the plane aperiodically with an almost 5-fold symmetry. Does this mean there is only one pattern of kites and darts, and every picture that we see is just a portion of that overall singular pattern? Well, the answer is no. There are actually an uncountably infinite number of different patterns of kites and darts that tile the entire plane. And it gets weirder. If you were on any of those tilings, you wouldn't be able to tell which one it is. I mean, you might try to look further and further out, gather more and more data, but it's futile because any finite region of one of these tilings appears infinitely many times in all of the other versions of those tilings. I mean, don't get me wrong, those tilings are also different in an infinite number of ways, But it's impossible to tell that unless you could see the whole pattern, which is impossible. There's this kind of paradox to Penrose tilings, where there's an uncountable infinity of different versions, but just by looking at them, you could never tell them apart. Now, what if we count up all the kites and darts in this pattern? Well, I get 440 kites and 272 darts. Does that ratio ring any bells? Well, if you divide one by the other, you get 1.618. That is the golden ratio. So why does the golden ratio appear in this pattern? Well, as you know, it contains a kind of five-fold symmetry. And of all the irrational constants, the golden ratio phi is the most five-ish of the constants. I mean, you can express the golden ratio as 0.5 plus 5 to the power of 0.5 times 0.5. The golden ratio is also heavily associated with pentagons. I mean, the ratio of the diagonal to an edge is the golden ratio. And the kite and dart pieces themselves are actually sections of pentagons, same with the rhombuses. So they actually have the golden ratio built right into their construction. The fact that the ratio of kites to darts approaches the golden ratio, an irrational number, provides evidence that the pattern can't possibly be periodic. If the pattern were periodic, then the ratio of kites to darts could be expressed as a ratio of two whole numbers, the number of kites to darts in each periodic segment. And it goes deeper. If you draw on the tiles not curves, but these particular straight lines, well, now when you put the pattern together, you see something interesting. They all connect up perfectly into straight lines. There are 5 sets of parallel lines. This is a kind of proof of the five-fold symmetry of the pattern. But it is not perfectly regular. Take a look at any one set of parallel lines. You'll notice there are 2 different spacings, call them long and short. From the bottom, we have long, short, long, short, long, long. Wait, that breaks the pattern. These gaps don't follow a periodic pattern either. But count up the number of longs and shorts in any section. Here I get 13 shorts and 21 longs, and you have the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. And the ratio of one Fibonacci number to the previous one approaches the golden ratio. But inspired by Penrose tilings, they designed a new kind of structure, a 3D analog of Penrose tilings now known as a quasicrystal. And they simulated how X-rays would diffract off such a structure, and they found a pattern with rings of 10 points, reflecting the five-fold symmetry. Just a few hundred kilometers away, completely unaware of their work, another scientist, Dan Schechtman, created this flaky material from aluminum and manganese. And when he scattered electrons off his material, this is the picture he got. It almost perfectly matches the one made by Steinhardt. He said if you have rules for the vertices, the way the vertices can connect with each other, those rules are strong enough locally so that you never make a mistake, and the pattern can go on to infinity. One of the seminal papers on quasicrystals was called De Neva Quinquangula on the pentagonal snowflake, in a shout-out to Kepler. Now, not everyone was delighted at the announcement of quasicrystals, a material that up until then people thought totally defied the laws of nature. And quasicrystals have since been grown with beautiful dodecahedral shapes. They are currently being explored for applications from non-stick electrical insulation and cookware to ultra-durable steel. And the thing about this whole story that fascinates me the most is what exists that we just can't perceive because it's considered impossible. I mean, the symmetries of regular geometric shapes seemed so obvious and certain that no one thought to look beyond them. That is, until Penrose. And what we found are patterns that are both beautiful and counterintuitive, and materials that existed all along that we just couldn't see for what they really are.